Welcome to G Fun Facts Online. In the savannas of Africa lives a creature whose name alone inspires respect and fear. A creature so fast, its venom can deliver a fatal blow to a human in as little as 20 minutes. We're talking about the black mamba. But what makes its venom so devastatingly effective? It's not just one poison. It's a highly sophisticated chemical weapon, an evolutionary masterpiece that wages a two-front war on the body. Today, we're deconstructing the chemistry of this superpoison. The venom of the black mamba is a complex cocktail, a symphony of toxins fine-tuned over millennia. A 2015 analysis revealed at least 41 distinct proteins and peptides working in concert. Unlike many snake venoms that cause massive tissue damage at the bite site, the black mamba's venom is designed for speed. It's primarily neurotoxic and cardiotoxic, aiming for a rapid, systemic shutdown. This venom composition is an adaptation to its prey, primarily small, fast-moving mammals. To catch them, the snake needs a fast-acting solution. This solution is a dual-attack strategy targeting the nervous system and the cardiovascular system simultaneously. Let's start with the neurological assault, the effect the black mamba is most famous for: rapid, progressive paralysis. This isn't a single action, but a coordinated, two-pronged strike that dismantles the communication between your nerves and muscles. This point of communication is called the neuromuscular junction. First, we have the presynaptic strike, carried out by a group of proteins called dendrotoxins. To understand their function, think about how a nerve tells a muscle to move. An electrical signal, an action potential, travels down the nerve. When it reaches the end, it triggers the release of a chemical messenger called acetylcholine. This messenger crosses the tiny gap to the muscle and tells it to contract. To keep this process from running wild, the nerve cell has to reset itself. It does this by opening tiny gates called potassium channels. Dendrotoxins are molecular saboteurs. Their one and only job is to find these potassium channels and block them. With the gates jammed shut, the nerve cell can't reset. The action potential is prolonged, leading to an uncontrolled, massive release of acetylcholine into the synapse. The nerve is essentially screaming "go, go, go" at the muscle without being able to stop. This initial phase of hyperexcitability is what causes the muscle twitching and convulsive symptoms seen in victims. But while the dendrotoxins are causing this chemical flood, another group of toxins is already working to make it completely useless. This is the postsynaptic blockade, carried out by alpha neurotoxins. These belong to a family of molecules called three-finger toxins because of their shape. These toxins work on the muscle cell itself, at the receiving end of the signal. They target the nicotinic acetylcholine receptors. If acetylcholine is the key that unlocks muscle contraction, these receptors are the locks. Alpha neurotoxins are what we call antagonists. They bind to the receptors, fitting into the lock perfectly, but they don't turn it. They just sit there, blocking the keyhole. So while the dendrotoxins are causing a massive flood of the key acetylcholine, the alpha neurotoxins have already plugged all the locks. The muscle receives no signal to contract. The result is a complete shutdown of communication, leading to a limp or flaccid paralysis. This is why a victim's eyelids droop, their speech slurs, and eventually their diaphragm and respiratory muscles stop working. As if this wasn't complex enough, recent research has uncovered an even more insidious part of this attack. Scientists found that the venom can initiate a dual or biphasic neurological assault. The first phase is the classic flaccid paralysis we just discussed. But even if a victim receives anti-venom, the presynaptic dendrotoxins can linger. Once the immediate threat is neutralized, these lingering toxins can trigger a second, delayed attack, a spastic paralysis, causing painful, uncontrollable muscle spasms. This discovery solved a long-standing clinical mystery of why some bite victims would improve with anti-venom, only to relapse with severe spasms later. So the nervous system is under a multi-stage, comprehensive attack. But the black mamba doesn't put all its eggs in one basket. As the neurotoxins are inducing paralysis, a separate suite of cardiotoxins is launching a direct assault on the heart. One of the key players here is a peptide called calcicepine. Its name gives a clue to its function. It is a highly specific blocker of L-type calcium channels. These channels are crucial for the contraction of heart muscle and the smooth muscles that line your blood vessels. By blocking these calcium channels in the heart, calcicepine reduces the force of its contractions. The heart beats more weakly, causing a dangerous drop in blood pressure and leading towards circulatory collapse. The same effect on the smooth muscles and blood vessels contributes to this hypotension. Other cardiotoxic components in the venom can directly kill heart muscle cells, a process called cardiomyocyte death. The venom is also associated with a range of cardiac arrhythmias, from a dangerously fast heart rate to ventricular fibrillation, which can lead to sudden cardiac arrest. The true lethality of the black mamba's venom isn't just in the individual power of these toxins, but in their synergy. They work together to create an effect far greater than the sum of their parts. On the neurological front, you have a push-pull effect. The dendrotoxins push by flooding the synapse with the go signal, while the alpha neurotoxins pull by blocking the receptors. It's a guaranteed shutdown. At the same time, the cardiotoxins are weakening the heart and collapsing the circulatory system, just as the neurotoxins are paralyzing the muscles needed for breathing. It's a perfect storm of physiological failure, leaving an incredibly narrow window for medical help. A bite from a black mamba is a top-tier medical emergency. Symptoms appear within 10 minutes, often starting with a tingling at the bite site, a strange metallic taste in the mouth, and then the classic drooping eyelids and slurred speech. The only effective treatment is the rapid administration of a polyvalent antivenom, which contains antibodies that bind to and neutralize the venom toxins circulating in the bloodstream. Alongside antivenom, intensive supportive care, like mechanical ventilation to keep the patient breathing, is absolutely critical. Now, after hearing all of this, you'd be forgiven for thinking this venom is purely an agent of destruction. But here's the fascinating twist that we so often find in nature. Within this deadly chemical arsenal lies a potential treasure trove for medicine. Scientists are now deconstructing this venom, not to just understand the killer, but to find new life-saving drugs. The most promising discovery so far is a group of peptides called mambalgins. In studies, mambalgins have shown a pain-killing effect comparable to morphine, one of our most powerful analgesics. But here's the game changer. They appear to achieve this without the major side effects of opioids, like respiratory depression and, most importantly, the risk of addiction. They work through a completely different biological pathway, by inhibiting something called acid-sensing ion channels. This makes mambalgins a revolutionary candidate for a new class of non-addictive painkillers. And it doesn't stop there. Other toxins, like one named MT9, specifically target receptors that regulate the tone of our arteries, making them potential models for new cardiovascular drugs. This isn't without precedent. Some of the most widely used blood pressure medications today, ACE inhibitors, were originally developed from peptides found in the venom of a Brazilian pit viper. So the venom of the black mamba is a true marvel of evolutionary engineering. It's a coordinated dual-attack chemical weapon that combines a sophisticated neurological shutdown with a direct cardiac assault, ensuring a swift and efficient end for its prey. It is, without a doubt, one of nature's most formidable creations. Yet, by carefully picking apart this super poison, we're discovering that the very molecules that make it so deadly hold the keys to treating human suffering. From the heart of a killer, we may find the future of healing. Thanks for listening to G Fun Facts Online.